This is electricity, one of the most important topics like kinematics, like dynamics, like nuclear physics. This is an every year chapter. So I'm coming back to that. Define the ohm, and you know the definition comes from the formula R is equal to V upon I. So can you recall the definition for me, the definition for electric current?
Joules per coulomb.
No, you can see in front of you ohm.
Voltage
So
over ampere.
ohm is equal to, but do you remember as I told that how you define a unit? You can't simply say volt per ampere. You have to you have to put 1 with every unit. Now, can you make a definition from it? 1 ohm is the resistance when there is 1 volt of PD
Across 1 ampere.
for 1 ampere. A 15-volt battery with negligible internal resistance is connected to two resistors P and Q as shown. Now, you have read the question. The resistors are made of wires of the same material. The wire of P has diameter D and length 2L. The wire of Q has diameter 2D and length L. The resistance of P is 12 ohm. Now, it's same material, right? The main thing is the same material. What is this row standing here?
Resistivity.
Yes. I've written the formula. I can cancel Something is going wrong. Getting a wrong answer. Just let me, you can also help me out. I'm getting a wrong answer. Acha, I have put the diameters in the wrong way. Actually, it is D2 upon D1. So D1 is D. So this is the mistake. Let me correct it. It was diameter D1. That should come D here.
So how would we know like where to put which value?
You can call anyone as 1 and anyone as 2. So I have taken P as 1 and I have taken, it's a ratio, so you can take any choice. But I had inserted the value in the wrong way. It's D2 upon D1. Look, this is the mistake. Share the working. Calculate the total power dissipated in the resistors P and Q. So we can, how should we do that? We need to get the total power dissipated in the two resistors.
First, we can find the
Sorry, your voice cut.
resistance and use V square over R.
Actually, your voice was not clear.
We can first like find the resistance in parallel.
In parallel, voltage is the same. So we are getting the same voltage for both of them.
Can you hear me now?
Yes, now the voice is clear. I'm putting 12 and voltage is 15. So I'm using this formula, and in parallel, power is divided and conserved in both parallel and series.
So we could also like find the total resistance and then do it.
Sorry, total. No,
Resistance
that
like with
would
the
be fine. I didn't try that yet, but that would be a bit risky because in parallel resistance decreases. But you can try that. I am not sure if it works here, but I think it's safer to use separate formula. Let's try that.
the P1 is 18.75.
18.75.
Yes, and the P2 is 150. The answer is 168.75.
So I can write it as I have written it 170. Determine the ratio average drift velocity of the charge carriers in P and in Q. The formula says he is making a ratio. Material is the same. So same material means it would be same material means that resistance, sorry, number of charge carriers per unit volume, number density would be the same. It's a wire, so area would be देखो अब तुम इसमें अगर ऊपर रखोगे तो ऊपर 2 का मतलब होगा 1.5, और d2/d1 का मतलब होगा ऊपर होगा 2d और नीचे d। ये सारी वर्किंग शेयर करना ताकि पूरी प्रैक्टिस हो जाए, क्योंकि काफी लंबी चौड़ी वर्किंग है।
The answer is coming as 0.5.
हम्म अब जा रहे कि ये पूरी डेरिवेशन की तरह की वर्किंग है। Electric current is a flow of charge carriers. The charge on the carrier is quantized. Explain what is meant by the term quantized. Quantized नया टॉपिक है, 2016 में आया था, बहुत कम कम पेपरों में आया, बहुत कम पेपरों में। उसकी क्या डेफिनेशन थी कि चार्ज ऑन एनी सब्सटेंस और एनी पार्टिकल इज एन इंटेग्रल मल्टीपल ऑफ द चार्ज ऑफ एन इलेक्ट्रॉन। ये डेफिनेशन याद होनी चाहिए। Charge on any particle is an integral multiple of the charge of an electron. A battery of EMF 9 volt and internal resistance 0.25 is connected in series with two identical resistors. There are 2x. This is the working using the EMF formula.
The answer is coming as 2.76.
Uh, 2.76.
Yes.
Calculate the potential difference across the battery. Now, he's talking about actually external PD or terminal PD. So for terminal PD, we have to consider the external resistors only.
So will it be like V is equal to I plus small r plus V I R, the capital R?
We have the current is fine, but we have to recalculate the resistance. We can't take all the resistors, we can't take the internal resistance. How much would be the external resistors?
3.2, 3 ohm.
That's fine. The 2.76, sorry. Now this is the working.
It is coming as 8.28. So in this, the internal resistance won't be counted.
Yes, because terminal PD means what the user is getting.
Like in all potential difference, we'll have to say like only the terminal PD.
Whenever you want to get terminal PD means what you are getting, but the internal resistance should be avoided. So can you tell me how, I actually forgot what the answer was?
8.28.
Each resistor X connected in the circuit is made from a wire with a cross-sectional area. The number of free electrons per unit volume is this. It means this is N, this is A. He's asking for current. Millimeter square.
The answer is coming as 8.14 into 10 power minus 6.
Can you repeat, please? 1 point.
8.14 into 10 power minus 6.
It's coming very small. -6. It's coming very small. But it can be. Obviously, it's a conductor. But anyways, looking very small. Double check the calculation. Then we should move forward.
It is coming the same.
Okay. The two resistors X are replaced by two resistors Z made of the same material and length. Length is the same, but half the diameter.
So resistance will be doubled. The four
The
times more.
diameter, the ratio, length is the same. Ratio comes with, in diameter case, the ratio comes in a square. The ratio of half will become 4. So the resistance of Z increases. Now resistance and current are inversely proportional. So current, resistance increases, so current decreases. I is inversely proportional to drift velocity. So drift velocity will decrease. You can see the whole concept sequence and you can ask if you have any confusion. It's a long explanation actually.
So the I is inversely proportional to the drift velocity.
You can see from this formula, na? You can see V and oh, actually, I think I overlooked.
With more resistance, won't there be more current?
The point is that this is right, the current will be decreased.
Because of R is equal to V over I.
This is a point. R is proportional to resistance and current are inversely proportional. That's right. Current goes down. Current and velocity are, and I missed it because there is a slight confusion because why I have written drop. There's a small mistake here.
So it will be the same, the 1 volt passing through the 1 ampere current.
This is the same definition. A cell of EMF 1.5 volt and negligible internal resistance is connected in series to three resistors. Connected in series to three resistors A, B, and C. Resistors A and B have resistances 6 and 3 respectively and are connected in parallel. Resistor C has resistance 4 and is connected in series. The current in the circuit. So first we should find the effective resistance. Six and 3 are in parallel. So we can solve it in parallel. And 4 is in series.
The answer is coming as 0.25 ampere.
0.25. Then he says the current in resistor B. You can apply a ratio method because current divides in parallel. Current divides in parallel, it's 6:3. I want to get the current in resistor B, but I will be using the ratio 2 because current divides in opposite ratio.
It is 0.167.
Now, this is the key concept here. The ratio power dissipated in resistor B and power dissipated in resistor C. Voltage we do not know, but we know the current in B. We should first find the current in A. In parallel, current is divided and conserved.
IA is 0.083.
Now there is a mistake because I didn't see that the resistor was C. Actually, he's making a ratio with current in resistor B with resistor C. So this calculation was not needed because current in B we already have found, and C obviously will be getting the full current as it is. The value of RC is 4.
It is 0.35.
0.35.
35.
The resistors A, B, and C in B are wires of the same material and have the same length. Explain how the resistors may be made with different resistance value. So if length is same, material is same, so we can change their diameter.
The area can be changed.
Yes. Part 2. It's the same derivation, but it is always ideal to do how many times it comes back, doesn't matter, but always keep on doing it so it comes in a memory line. In resistor B and resistor C. So when you say V1 upon V2, B and C are wires of the same material. So we can take the same N. Now the problem is area. We have the current, but the problem is coming area. How we can find the area?
Won't we take it the same? Because it's the same wire.
No, he same wire no, he has not said the area same. He has said, if you read the question, he said length is the same and material is the same. Our course says resistance is inversely proportional to area. So R1 upon R2 is equal to A2 upon A1. So I'm trying to use this plan and I have to I have updated the formula. We have the current in B, that's 0.167. Resistance of B is 3.
It is coming as 0.5.
The cell of EMA 1.5 and negligible internal resistance is connected in parallel with cell X in figure 6.1 with their positive terminals together. So he is connecting another cell here. यहाँ पर. The previous cell was 1.5. The new cell will also be 1.5. So state the change, if any, to the current in cell X. In parallel, effective resistance decreases, and up cells combination, the current decreases or increases.
If resistance decreases, then the current will increase. Because of R is equal to V over I.
No, he's talking about cell X, not the total current. Total current is fine.
It will be the same.
A cell of EMF 1.5 volt and negligible internal resistance is connected in parallel with cell X in the figure with their positive terminals together.
So will the current decrease?
This is a point because he's specifically asking for cell X. So what will happen to one cell?
Because
Because
of the two positives.
we have to see what was our total current. That was 0.25 was our total current. The effective resistance will decrease. The 1.5, 1.5, both will be producing once you make the combined circuit. And what would be the combined voltage? Can you tell me in parallel? Will it still be 1.5?
Parallel voltage is the same.
Yes, good. Parallel is the same. Our total current was 0.25 in our previous calculation. The total current we found here. Our total current was 0.25. and we have to decrease the circuit. So in parallel, effective resistance decreases. Now, how much current will, if both of them will give 0.125?
So the current will decrease because the voltage will stay the same.
But they both are, look, cell X is producing 0.125 and cell Y, the new cell, is also producing 0.125.
So resistance will have no change.
No, the current will not change. Current will be the same.
And effective resistance will decrease.
Effective resistance will no, I think I'm not able to clear it now. You have to see the diagram. Actually, they are changing the cells. They are making some change in the cell. There is no change in the external circuit. So they are changing here only. So the cells will have a less resistance, that's right. But there is no change in the resistance of C. Now there are two cells in parallel. If you now look at this diagram, there are two cells in parallel. Each cell is producing 0.125. Each cell is producing 0.125. So together the total current will remain 0.250.
I got it now. I got it.
So we keep it up to here and we will do it in our next class, inshallah. Allah Hafiz.
Allah Hafiz.